The Ben Heck Show is brought to you by Element14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element14's The Ben Heck Show.
Hello and welcome back to the Ben Heck Show, special holiday edition. In the spirit of Santa Claus, I thought it might be cool to play the part of an elf and build a cool holiday present for a little girl or boy. So I was thinking back to the days when I was a little boy, which is approximately 5 billion years ago. I thought robots and tanks were cool. So I found these things laying around my shop, tank treads and the gearbox. I think it might be cool to put these kits together just like an elf and then build it into some sort of autonomous robot tank. I'd better get started. Off to the workshop. So this plastic gearbox kit has a bunch of parts in these little bags and we're going to put it together. Basically it has two sides, a left and a right, and they're mirror images of each other. So you build it one time and then you basically build a copy of it mirrored and put them together. The important thing is to make sure you're using the right shafts and they're all pointing in the right direction, but the instructions, although quite detailed, are pretty easy to follow. So I'm putting a set screw in here to make sure the drive shaft works and everything freely spins inside of these grommets. Okay, there's the first set of gears. Pretty good gear reduction on this too. I think it's around 57 to 1. All right, now I'm building the opposite side. So basically it's a mirror of what I already did. And it goes together pretty well. And there's another drive screw right there. And we're gonna clamp it together and it is now one solid piece. So you put the motors in here and they engage with the gears at a right angle, giving us the power we need to move whatever it is we're building. So here's my tank tread set, another kit. What I have to do is see how much tread I have total, and of course I need two sides. It turned out to be about 17.5 inches of linear tread per size. So that's actually going to dictate where I place my wheels. This tread set was neat, but it didn't come with a frame. I had to design my own, which is a little tricky because you had to figure out the circumference of these drive wheels versus how much belt I actually got, or tread. But I came up with something pretty good. I made this test rig here, and now I'm going to use the one I just lasered to build it. Here's how I figured out the position of the wheels. I knew I had 17.5 inches of linear tread to work with, and that's measured off the inside of the tread where it actually contacts the wheels. It's represented by these shapes here. And these represent our wheels. These are idler wheels and this is the driver wheel. So at 17.5, that had to be the total length. So these main lengths are pretty easy to figure out: 4 inches, 3 inches, 6 inches. The wheels are a little trickier. I had to take, well, you use circumference to figure out, the distance around a circle. But the treads don't actually go all the way around a circle. So what I had to do was figure out at what angle these actually hit the thread. So this is at 0 degrees and that's probably about 170. So I would take 170 degrees of actual tread, divide by 360 and then multiply it by the circumference. So in this case, there's actually 1.66 inches of tread on it, 0.78 contact there, and 1 inch contacts there. Once I knew what the number was, 17.5, I was able to work the wheels out to fill it up as close as possible so the treads aren't loose. So the parts to run this project are a battery pack, which we have here. It's going to go onto this plate. This is going to be attached here underneath, so you can still get at the batteries. Then up here, we'll attach this entire Arduino and motor shield. This motor is a little overkill, but it'll be all right. And then our drive is actually gonna go up here at an angle. And there's gonna be a front panel to place sensors. I'm gonna start with the lowest part, the battery pack. I'm gonna drill these holes manually for the Arduino just because it's faster than measuring them. There's probably a template someplace, but a lot of times it's faster to do things by hand than to use the computer. And I need to make sure all these parts are installed onto these plates because I'm going to press fit the sides of the unit together, and then it won't be very easy to remove them afterwards. Not impossible, just not very easy. All right. So this will install here, and then when we're ready, we can plug on the motor shield. Wish these wires were a little longer, but whatever, we'll make it work. Ugh, that one broke. That's not good. One of these days I just use, nah. I have wire strippers, I just don't use them. Well, sometimes I do. So I'm kind of putting this together in halves. So once I put everything in this half, then I will clamp on this side to complete it. So we've also got this guy here. This is where we'll probably put some of our sensors. Not really sure what I'm going to use for sensors yet. Oh, actually, I need to redesign that. I realized I made a mistake. This is where the motor's going to go. Take off one of these wheels. Put the shaft through. Yeah, see, the mistake I made was this needs to have an opening to go around that. And the opening needs to be a certain, it's about 3/8. Okay. So the size of this is based off of the press fitting of these wheels. So the shaft width actually dictates the entire width of this unit. All right, that looks pretty good. Okay, I'm gonna re-laser this before I go any further. Before we go any further. Now it's time for a tech timeout. So today's project, we're using motors and a motor driver, so I think it'd be cool to talk about an H-bridge. Now you can make an H-bridge yourself using transistors, well, hopefully large transistors, and a motor, but this is basically how it works. You have your positive supply voltage for your motor here. This isn't necessarily your logic voltage. This is probably gonna be 12 or 24 volts. And you have two transistors here that it goes into and two out here. But the trick is you only activate two transistors at a time. You're either activating these guys or these guys. And what happens is if you're activating these guys, positive voltage comes this way, goes out this way, which makes the motor spin in one direction. If you only activate these guys, it goes this way, making the motor spin in the other direction. Now most motor driver integrated circuits you might get usually is going to have two H-bridges on it, so you can drive two motors. And this stuff will go through other logic, so basically you'll just put in a 0 or 1 for each H-bridge. So you'll usually have a pair. So like if you have two ones, that's both motors forward, 0 is coast or off, and then 1 0 or 0 1 is left or right. That's what we're using for our robot. So yeah, it's pretty easy. You know, I would say, you know, use an integrated circuit if you can, because then you don't have to worry about this, it's already done for you. But it shows that basic way that they are put together. It's called an H-bridge because it kind of looks like an H. Trying to shrink your own computer to the size of a Raspberry Pi? Not easy. Accessing Raspberry Pi tips, tools, accessories, discussions, and more on the Element14 community? Much easier. Discover all the ways we're building an easier experience at element14.com/evolution. Now there's room for it. All right, so let's take this guy off. This is garbage. This is crazy. Here's my robot, so drive it maybe. Bad robot. Lasers are really good at doing stuff like this. I'm not so good at aligning it. Oh, there you go. If we can hit that bullseye, the dominoes will fall like a house of cards. Checkmate. These were magnetic. Have to resort to gravity. Your favorite movie? Ah! Sandra Bullock in space. Yeah, nice and solid. Rolling in the deep. All right, time to put the treads on. It should fit, I hope. My amazing calculations are correct. If they are. I think they're close enough. Cool. Tank treads are cool. These treads are in what's known as a Wally configuration. Oh, I forgot my idler wheel. Good thing I was playing with it, so I remember. I'm going to put idler wheel right here. And it could run over things better if it was sloped upwards, but I like the way this looks. What else can it run over? Well, it seems to roll around a lot. It's fun just to push, but we're going to make it motorized and give it kind of some brains.
Our little tread robot is just about done, but we need to wire him up first. I'm going to make some twisted pairs of wires to connect the motors to the motor driver board. We'll also need to connect the battery pack to a power switch, then connect that to the input on the power driver board, which will also regulate our power for the Arduino. Then I'm going to install this ultrasonic rangefinder, which will detect objects. So our unit is just about ready to go. We just need to program him.
Okay, so let me show you where we are with this guy. Here's an off-brand ultrasonic distance detector. Basically, it sends a wave and gets it back and figures out the timing. This is pretty much what we used on the robot luggage. Then there's the gearbox that we put together, battery pack, and on the back here, Element14 sent us this motor shield for Arduino. So that was quite easy. We basically just hooked it right up to the motors and it plugs right into an Arduino, which they also supplied. Even has headers for data and whatnot, so I'm just using this header here. It's supposed to be for I2C, but we can still use it for the ping sensor. So this guy's pretty much all ready to go. He just needs some logic. So the logic I'm going to make him do for our demonstration is it will look to the left and look to the right and take measurements and see which direction has the most distance available based off its sensor. And then it will turn to that direction and proceed until it gets to an obstacle, in which case it will back up and look for a direction again. So you could use this as a rudimentary maze exploration routine. So I'll get it flashed and then we'll do a demonstration. Unplug this, plug him in, make sure the code is ready, and upload. Now the little robot is programmed, it's time to see what it can do. It's escaping the test course. It's camera shy. Oh, we should give it some stuff to run over. Oh no, it's off course! Well, that's a nice little present to put under someone's tree. That's all the time we have for today. In our next episode, we're going to be using 3D Systems' new Sense scanner to scan three-dimensional objects. We'll see you then.
The Ben Heck Show is brought to you by Element14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.